Hey guys, it's John, and today's video we are gonna go over the linear search algorithm in Java. In this video you're gonna learn everything in the linear search algorithm and searching in an array, how to search an array, how to find a key in a certain index, or how to find an index in with the certain key. So in this video I have the roadmap, like what I'm gonna teach, what I'm gonna show, and what kind of questions we're gonna solve. So I'm checking it right now. First we're gonna go over the what's linear search and what's the time complexity of that. Then when should we use the linear search? What kind of situations that we should use the linear search or we shouldn't use linear search. Then we are gonna go over the regular linear search on the arrays. After we do the arrays, we are gonna go over from the strings. After that, we are gonna do the recursive linear search on arrays. Then we are gonna do some improvements on the linear search, which is transposition, move to front, and the Sentinel linear search improvements. Let's not wait for more and let's go back to the screen. Okay, now let's start. So first of all, what's linear search and what's the time complexity of that? So linear search is, let me just show you a real example. We have an array, right? And this array have 4 elements. And we gotta find the element which is 2, okay? So it's right now, this array has 4 elements and 2 is on the second index. Sorry, the first index. The 0th index is 1, the first is 2. So we are gonna call the linear search function, and we are gonna send the array and also the target. Then let's create the linear search algorithm. It's going to return an integer, or it can return a boolean also, but I'll show you from the integer. It will take an array and target. So first of all, in the linear search algorithm, we gotta check if the array is empty or not. If array is empty, we gotta return a -1. This is the first rule. You always have to check this one in the linear search algorithm. So the second one, the second thing, we gotta iterate all the array, index by index, one by one, every element, and we are going to check element is if the target key is one of the elements or not. So we are going to create a for loop, and we are going to do it until 0, from 0 until the array.length. We are going to check if array e equals the target. If it's equals, we are going to turn the index of that array. Then actually we're just going to leave it like this. Then if it's not, it's going to go through the loop one more time. Then if it goes out, if it's not returning anything, let's return -1 again. This is what the linear search is. So let's check. Then we gotta use the static, of course, here, because I don't want to create any object from main class. Then we are gonna see the index of 2. Sorry, the first. As you can see, here is the first index. We can also return the key itself. I'm just gonna copy this one. Then we are gonna go over the time complexity of the linear search algorithm. So this one is going to still be here. Then in this case, we are gonna do the elements, integer element in array. This will be elements, then it returns the element itself. Then this one will be, actually let's not use the integer thing. Actually, we don't need to use this thing because it's not going to get in the loop. Yeah, then we're gonna return the 0 if it's not the element itself in the array. So in my opinion, we gotta use the boolean, then if it's correct, return true. If it's not, return false. Then if you want, this helps you to find if the key is in the array or not. It's the easier way to find. So the time complexity of this linear search algorithm, in the best case, will be the O1, because in the best case of the linear search, you're gonna map the loop for one time, and you're gonna find the element in the first time. This is the best case. But the worst case will be always the size of the array, which can be 5, 1,000, 1 million. We never know. The size of the array will be the n. Time complexity of that algorithm will be O, big O, n, where the n is array length. This is the time complexity of the linear search algorithm. I'm gonna show you the Sentinel linear search, move to front improvement, transposition improvement, but every one of them, the worst case will be ON. Okay, just don't forget this. Okay, so why should we use the linear search? The answer is, let me create a comment. Small data sets when we are searching a data set stored in contiguous memory, or when we just want to implement a simple algorithm. So if you have a data set with like 1 million data in it, like not this one, 4 elements, if there is like 1 million elements or 100,000 elements, it doesn't make sense to use linear search. We gotta use the binary search or the hash maps or linked list or something like. Can't use the linear search with big data sets, okay? So if we are searching a data set stored in contiguous memory. So what is contiguous memory? Consecutive blocks of memory allocated to user processes are called contiguous memory. In this case, if a user process needs some X bytes of contiguous memory, then all the X bytes will reside in one place, in the memory that is defined by a range of memory address. It's kinda, you know, the memory part. You don't need to actually fully know that thing. Let's say this kind of memory here, and then to another range. Let's do some kind of, you know, like this. If we know this is the range where the data stored in, we can use linear search because we know how much is going to take. You know, it's not still ON, but mostly you don't need to know that. And also, if you want to implement a simple algorithm like this, you know, find the minimum number, find the maximum number if in this array which has 10 elements. Like this, we can use the linear search algorithm. So let's go over the regular linear search on number arrays. We actually do that here in the first example. Let me just, you know, take this. We can find an element like this. We can, you know, find different elements like let's try to find a 3. It's going to turn 2. Cool. So if you want to search on the strings, let's create a code here. We have a string, okay, and this string is, let's say, John. Trying to find the J. Okay, this is the target letter that I want to find. And let's create a linear search strings, and it's going to take a string, the whole string, also the target string. Let me take this from here, then put a target string. So I'll create a copy paste this, then open this. It's going to return a string. Sorry, it's going to return an integer, and this is the way. Let's create target string here. Okay, so we should use, still we gotta check the string, the whole string has something in it, you know. The length shouldn't be equal to 0. If it equals to 0, it's going to return a -1. If it's not equal to 0, let's go over. We're gonna do this until the length of the string from the 0. Then every index we gotta check string to char at I. Then the target will be this. I think it doesn't occur an error. Yeah, perfect. This time we're gonna see the 0. Yep, here you go. If we are searching for H, we're gonna see 2. Cool. Everything works perfect. This is how we search in the strings. You can search double strings here also, like this, but it's not like with the char. You can search also double or triple letters, triple words in a word, but we are gonna go over that later, okay? That's how it is. You can search on strings like this. So the fifth thing is recursive linear search on arrays. So how to do a linear search in an array using the recursive algorithm. So let's go over. So I'm gonna use actually I don't need to do, let them stay there. Okay, so I have an array, then this array will have, let's say, 10, 20, 40, 50, and 60, okay? Has 5 elements in it. So the target will be 40. Let's say it's going to be 40. Then I'm just gonna system out print line, linear search recursive. It will take the recursive array, target recursive. Okay, I'll take this one from here, then create a new function which returns integer. Then the array will be here, of course. Also the target recursive will be here. So first things first, we're gonna check the recursive array dot length is equal or not, equals 0 or not. If it's equals 0, it's going to return -1. But I forgot something to do. I gotta send the size of this array also, recursive array dot length here, and this will be the integer, of course, the size array. Then we gotta use the size of array here. Okay, sorry guys, size of array. Then the size of array will return. Then if it's not, size of array -1. You know, we are gonna check the previous element. You know, we are right now we are in the first time we are checking the last element. If it's not, we are gonna check the previous element. Let's return this, of course, or return -1. But yeah, we gotta use the size of the element, size of the things like this. You know, we gotta check in the first time. Let me delete this. Yeah, we gotta do this like that. And this array length will be the size of array, because every time the size of the array is going to change. Yeah, that's how it is. Let's try to find, we're gonna see the second thing in the liner search. Yeah, as you can see, let's try to find 50. We're gonna see the 3. That's how the liner search algorithm works. So how it works actually, let's try to, you know, debug this and see what's going on in the backside. So right now size of the array is 5, then the target recursive is 50, then the size of the length actually, then the size of array -1 is 60. Let's go. Size of the array is not 0. It goes to another check. Size of the array is right now 5. Let's go. It's going to the else. These words. Size of array is 5. Target recursive is 50. Let's go again. Right now size of the array 4. 4 equals to 0? No. Let's go. Then it's checking the fourth element. It's starting from the right side of the array. And yes, 50 is equals to 4. Actually the target recursive element. Then it goes up, finding the last thing, as you can see, and the function, the program over. So this is how the recursive function works in linear search algorithm. So I'll show you the transposition. What is the linear search transposition in the linear search algorithm? Let's go over that. I am just going to you know, take these things here. Actually it's better, let me write here one to use. Then let's put this two thing here like this, and let's close everything from that thing, put it like this. Then we're gonna go over the transposition in the linear search algorithm. So what's the transposition and how it helps? So transposition helps us if you are searching the same element next by next. You know, like we are searching today and tomorrow we are gonna search the same thing again. You know, if you are searching the same thing after and after in a certain period of time, we gotta use the transposition. If we are using the linear search, you know, we gotta use the transposition improvement. So in transposition, how it works, we are gonna use the simple linear search function in here. But let me just change the name, transposition. Yeah, we are gonna check the same thing. If array length equals to 0, is returning -1. It's the simple, every time happens, okay? But the thing happens in here. When we find the element index, we gotta swap the index with the previous index, okay? You know, we gotta take back, you know, we gotta put it the previous index, the normal index. If it's, you know, if it's at the 4th index, we gotta put that to the 3rd index, you know, 4th to 3rd. So how do we do that? Let's go. If the array index is equals to target, you're gonna return the index of that element. That's really cool. So how do we do returning stuff? We're gonna create a temp integer, then put the index of that array. Okay, actually we gotta put the array index 1. So I-1 will be equal to array.e, and the e will equal to temp. That's how you swap. Okay, we gotta use it like this. We're gonna check the, first of all we are gonna take the index element in the first side, then we are gonna put it we are gonna swap it in the end. But you know, we are putting in a temporary variable the normal element of that array. Then the normal element of the array will be equal to the previous element of the array. Then the previous element of the array will be equal to temporary element. That's how you do the swapping. Then in the end, it's going to return, you know, the index of that element. But if the I equals to 0, we gotta return the, you know, you gotta return itself, because we couldn't swap with the previous element of that array. That's how we handle the exception. Also, let me just put this here. Then that's the transposition. So it helps us, you know, like in the first time we are searching in an array. Let's create an array. Then the array will be 1 2 3 4. Then I'll try to display the elements first. Okay, then I will put the linear search transposition here. The target k will be, let's make the target 3. Then I'll check what's going on again. That's what I'm doing. Okay, so I gotta put you know, print line here. Then it will be helpful to see what's the difference. Okay, right now we are searching the number 3 in the array. Okay, so first of all, in the first time, the array is 1, 2, 3, 4, the normal sorted thing. But then we are putting a transposition. It finds the element and it returns the value of that element. Okay, if you want, we can just check the value. Sorry, not key. We couldn't use key. Where at? Let's say where at. Then we can use the where at. This can find where at also. Where in the second. Right now in this is on the second. Then if we do that one more time, let's put the where at second. As you can see right now, it's on the first position, the first key, first index of that array. If we are doing one more time, right now it's on the 0 index. Actually, it was on the first index, then it was on the second index, then right now it's on the first index. It's on the 0th index actually, sorry. So how we gonna use it? So as I mentioned earlier, if you're gonna searching the same thing, in a certain period of time again and again. So let's say you're searching a customer in a customer table, your customers around like 10 people. If you're searching the same customer every day, like maybe, you're trying to find it faster, this kind of things happens. If you're searching the same customer, you can just take that customer, previous indexes, then you can find that customer's data very fast, faster and faster, because it's always and always, even the small data sets, it's better to put the index that trying to find to the 0th index. If you're always trying to find the last index of that element of that array, it's getting more and more time. But it's better to put it, in the, as I mentioned earlier, it's better to make it O1, O1 better than O(n) every time and every time. That algorithm is helping us to find faster, that improvement actually. So we've done that. So let's try to put these things in a command line. I'll use this here. Perfect. Take this. So right now we are gonna do a move to front strategy, move to front improvement in liner search. Move to front is actually the same way with the transposition, but move to front is doing the element, the key will, after we find the key, that key will go to the 0 index, okay, index 0 directly. It's not taking like previous. No, it's not going to happen. It's going to go directly to the 0 index. That's how it works, the move to front improvement. Let's try to do. Okay, then if we find the key in a certain index, we are going to 4 to 0. Okay, index 0, the front of the array. So if equal to 0, it's going to return the same thing. But if it's not, we are going to take the index and put that index to the 0, and the 0 index will be the temporary. We are just taking the temporary here. That's fine. Now I'll use the same thing here. We're going to return, just two times. We are going to try to find the 3. Okay, I just forgot to write move to front. Let me take this, save, go. As you can see right now, it's on the first index, which is index 0. That's how the move to front works. Every one of them is O(n), okay? Never forget it. Liner search is always O(n), and O(n) is not the best case. Is the worst case. If you're liner searching in the 2D arrays, it's getting worse to use liner search. But if you're searching a small data set like 2 rows, 3 columns, it's okay. You can use liner search. You can get O(n), but it's okay. But if you're searching a big data set, it's getting worse and worse. Okay, let's go to the Sentinel liner search. I have a really cool experience about liner search. I actually can tell you about a little bit about this and how important Sentinel search is. So 3 years ago, I was trying to get into a company. Like, it was remote and it was Czech Republic based company, software company, and I was trying to get in the middle software engineer, software engineer 2 interview, and the phone interview was good. I passed it. The HR interview was still good. I passed that one. The third one was the coding interview. There someone is going to come, like the tech lead or some kind of guy. It was one of the guy from Czech Republics, and he asked me some technical questions. Okay, technical questions was good. It was good. I don't want to say it was bad. Like, like he asked me like around 10 questions about Node.js, and I knew I create some ideas about the 8 of them actually. Yeah, 7 or 8. I didn't know the another 3. I just couldn't couldn't remember. Sorry. So then, but the problem is the question that I didn't know, that I couldn't know actually, because those questions, one of those questions about the linear search algorithm, everybody knows the regular linear search algorithm, okay? Everybody knows it. But when it comes to the terms, when it comes to the specific terms, specific improvements on the linear search, sometimes you forget, or these kind of things are really rare to ask. And I'll add this video, maybe if someone asks you, you know what's going on. He asked me to explain the linear search algorithm. Okay, that's the simple. I just explain these things. We are going to search every index by index. Then if we find the index, we are going to return the index value. That's how it is. He says, okay, perfect. So could you please explain me the Sentinel linear search algorithm? I was like shocked. I just couldn't. I just didn't want to. I couldn't say anything because I don't know what the Sentinel is, what the Sentinel linear search is. Then I said like, wow, I never heard that algorithm before. Then, but if you can, maybe I did it before. Maybe I used that before, but I don't know the name. Can you please show me a way around it? Like, just give me an idea. He told me that the idea is when you're trying to find the index of the array, you gotta check when you're using the for loop, you're checking the array length every time, because you don't want to be max of bound, out of bounds, or max key of array exceeded. You have to check. Right now it's checking, but you have to check normally if you're using while loop. You gotta check the index of that array is in the array. You don't want to be in the exception called out of bounds. And to check this out of bounds, you should use if array if the size of array -1. We don't have to check is that the last element or not in the while loops. Normally you gotta check the while is that the last element or not. You gotta check it. But in the Sentinel search algorithm, you don't have to check. He told me like this. What is the algorithm that you don't have to check the size of the element every time, or is it the end element or not? And I was like shocked. I never use it. I never do that before. And I said, I'm so sorry. I don't know what's that. I know what the linear search algorithm. I know the improvements on the linear search, but I don't know the Sentinel linear search. And then we just go to the coding part. I passed the coding part, but then it was just failure of the general of the coding interview. He asked me a really specific question. Maybe it's because he just doesn't want to maybe hire me or something. I don't know why is that. But let's go over to the linear search. Let's go over to the Sentinel linear search and let's see what that is. First of all, I will just create the array again here. Okay, I'm trying to find the 3. So I will just say linear search, then Sentinel. Okay, I'll Sentinel array and also the target. So that's how it works. First of all, then let me take this one here. I actually don't need hold the fold function, but let's say linear search Sentinel. So I don't need this one for now. You can also put this here, but you won't need it. Okay, this is going to be on also. Let me just delete this from here. Now it's returning the -1. So in the Sentinel search algorithm, we are going to the index element to 0. Okay, first of all, let's try to when we are counting the array, when we are trying to find the array in the while loop, we are going to initialize that index element to 0. Okay, in the first time. Then we are gonna take the last element of that integer array and put it in a variable called last. That's how. After that, we are going to take that last element, then we'll make it the target. Okay, we are gonna act like we are trying to find the target element. We are trying to find the last element of the array. Then we are gonna open a while loop. The while loop will go over the index of array will not equal to key. Then every time the I will equal to increase by 1. So let's make this target. Okay, now what we are doing, we take the last element of that array and we put it in the last. like a variable. Then we initialize the last element of the array to target that we are trying to find. It means it's 1, 2, 3, 4. Right now it's not 1, 2, 3, 4. It's 1, 2, 3, and 3. Okay, the last two elements is the same, and we are holding the last element like this 4 because we don't want to miss it. We are not checking any if condition here, you know. We are not checking if the array is exceeds or something. Then let's put the last element to back, you know. Okay, we are putting back. We have the index of that array. If we find it, you know, if it's equal, it's not going to run this, you know, if it's not going to run this. Then if we are going to put an if condition here, if the index less than the length of array minus 1, I mean the last element, if index is less than the last element of that array, or the last element of that array equals to key, the target actually, it means we found the element, we found the index of also. It's going to return, or we're going to return minus 1. We can't find. We don't need to check the array size or sum. That's how the Sentinel search works. Okay, it's returning 1, sorry. Gotta return 0, 1, 3, 0, 1, 2. As you can see, we find the third element. This is what the liner search, Sentinel liner search is. You gotta use it like this. So I hope you understand anything in this video, and I tried to show you what is liner search algorithm and other things, you know, how to improve a liner search algorithm in Java, or what is Sentinel search liner search, and which is an improvement on the liner search algorithm. Liner search is, you know, we are gonna use it every time when we are struggling with the small data sets, but mostly we're gonna use with the big data sets, and we're gonna use binary search, hash maps, linked list, or something, you know. Just we're going to go ahead every time, because these kind of questions, liner search questions, they mostly asked on the junior software engineer interviews, junior Java interviews, or junior JavaScript interviews, like maybe if you're struggling with the backend, junior backend job interviews. These kind of questions in the liner search questions are always asking in the interviews, you know, the junior interviews. But the Sentinel liner search is a very simple, very specific thing, okay? Probably they are not gonna ask you, but when you are trying to get in a job which the role is the software engineer 2 or maybe mid software engineer, you gotta know what is Sentinel liner search, and you gotta know how to implement this algorithm, because they maybe want you to do this, but at least have an opinion, okay? Because when they ask me like, how is that working, what is Sentinel liner search, I couldn't say anything because I didn't know. I never heard that before, you know, like it's really normal. Sentinel liner search, what is Sentinel liner search? I don't really know what that is. But okay, right now we know, and you know, actually the experience is worth than gold. How do you say it? Experience is everything. So if they ask me again, I'm gonna just say what it is, you know, like how to implement that, what is the time complexity, of course, and that's how it is. Okay guys, so I hope you like this video. If you like it, just don't forget to like, and if you can subscribe it, I will be really happy. If you have some question in your mind, just ask me in the comments, and you can find every document or every source in this video on also the description below. See you in the next videos. We're gonna go over to Java deeper and deeper in the next videos. Thank you guys. See you again.